Yay!
All right,
Happy
you guys,
first
today
lecture of AP
we are
Psych.
going to
Whoop,
start
whoop.
by chatting
We're going to start
about
today by thinking, or specifically chatting about thinking, specifically concepts and decisions. So when we're talking about cognitive psych, cognitive, if you remember, you think back to those 5 psychological approaches, or well, the 6 including evolutionary, right? I had you draw your hand and there was all the different approaches. Cognitive approach is one of them, and that's we behave certain ways because of how we think, right? And that's what we're going to be digging into with this unit, and we're going to start it by doing a little demonstration here. So I want you to think and just follow these instructions silently as I go through them. Okay, you're just going to follow them and answer the questions one at a time as quickly as you can. Remember to choose your answers silently in your head. I guess since you're at home or listening to this elsewhere, it doesn't really matter if you say them silently or not, but whatever. And quickly, but do not advance until you have done each step. Okay? Think of a number between 1 and 10. Multiply that number by 9. Now, if the number is a 2-digit number, add those 2 digits together. Once you've done that, subtract 5. Determine which letter of the alphabet corresponds to the number you ended up with to find a letter. So 1 equals A, 2 equals B, 3 equals C, etc. I'll let you figure that out. Now think of a country that starts with that letter. Remember the last letter of the name of that country, and think of the name of an animal that starts with that letter. Now remember the last letter of that animal, and think of a type of fruit that starts with that. Are you ready to see some magic? Are you thinking of a kangaroo in Denmark eating an orange? Most people, I know, I'm a genius. Even from afar, I can figure these things out. It's not a trick at all. But in all reality, right, most individuals from Western cultures will answer kangaroos in Denmark when given this exercise because that's what they've been most exposed to. Now, there are other countries that start with D, right? You could think like Dominican Republic, Djibouti, Dominica, but for the most part, people in suburban Minnesota will come up with Denmark because it's, again, what they're most primed to think about. And so we're going to talk a little bit about what this example demonstration digs into when we look at availability heuristics, the influence of culture on cognition, expectation, schema, concept, prototypes. All of these ideas kind of fit into our understanding of why we were able to actually guess that. So with that, here are some of the ideas that we are going to be covering in this particular lecture. I'll let you take a look. If you want to pause and write those down, you're more than welcome to, but I'm not going to take too much time here. But the first one that we're going to be looking at are concepts. With that said, we are going to be fitting our ideas of what a concept is into our already known understanding of a schema. Remember, we talked about schemas when we talked about developmental psychology, when we talked about assimilation versus accommodation in Piaget's developmental stages, right? So we're looking at concepts, schemas, and prototypes, and what the differences are between these 3 ideas. So basically here, a concept is a mental grouping of similar objects, events, stages, ideas, or people. It can be represented and communicated by an image or a word such as chair or party or democracy, or in this case, right, fruit, right? Some of our schemas include things like, like avocados. Some of us don't think of an avocado as a fruit, right? Tomatoes. Are tomatoes in your concept of fruit, right? Do I know that the nerds in the room are going to be like, well, everything that has a pit or a seed is, in fact, a fruit? Yes, but I still don't really think of a tomato as a fruit, right? And so that wouldn't fit in my concept of fruit. Another example here is when we talk about triangles, how do we actually learn these concepts? And it starts with our understanding of a prototype. But a prototype really is a mental image of the best example of that concept. So if I were to ask you to draw a triangle, right? If you didn't see any of these, right? We didn't look at any of these. They're already there. But if I were to just ask you to draw a triangle, what type of triangle would you draw, right? If you imagine that in your brain, most of us would draw a right triangle. My mom will be so proud. She's a math teacher. We would draw a right triangle, and that is our prototype of a triangle, right? That mental image that best exemplifies our concept of a triangle. Do we know all of these things are triangles? Yes, right? But our best mental picture and our most specific mental picture that comes to mind when we think of a triangle is probably going to be a right triangle. Okay, so let's do an actual example of what these prototypes actually are. So I want you to take out a piece of paper, which you should already have out as you are taking notes, right? And I want you to respond to the categories I'm about to list, and I want you to give the very first example that comes to mind. Don't change your answer for a better one, okay? So you are just I'm going to read off 8 different categories, and I want you to write down the best answer, or the first thing that you think about, the first example that you think about when I say these, okay? Number 1, a bird. 2, a color. 3, a motor vehicle. 4, a sentence. 5, a hero. 6, a heroic action. 7, a game. 8, a philosopher. Okay, you should each have an example of each of those categories, right? A bird, color, motor vehicle, sentence, hero, heroic action, game, and philosopher. Now I'm going to try and guess what you said. And as we all come from a relatively shared cultural background, being from suburban Minnesota, obviously that is a vast overgeneralization of the diversity, cultural diversity within our community. But big picture, we're all from or living in Wayzata, Minnesota, and oftentimes being from the Western civilizations, we tend to have similar answers. Let's see what those might be. Did you, for number 1, say a robin or an eagle or a cardinal? Number 2, did you say red or blue? 3, a car. A lot of people also say motorcycle because motor vehicle primed their brain to think that way. Remember, back to memory and learning, priming. Number 4, a short declarative sentence like a boy ran home, a cat jumped high, whatever. Number 5, a hero, Superman, Batman, maybe a firefighter. A heroic action, right? Rescue by fireman, something specific to that. Number 7, a game, Monopoly or some other board game, because we said game and not sport. Generally, that's where people's minds go. And then number 8 would be like maybe a Socrates or Aristotle or Plato, right? If you were to ask these questions in Russia, right, you might have seen a philosopher being like Tolstoy or Chekhov. If you asked in Australia, they might have said kiwi for a bird, right? But these cultural similarities lead us to have similar prototypes regarding different categorizations. So we did this in class. I'm not going to take time. If you're interested, it's pretty cool to show like that how similar people's prototypes really are, that Google can guess what you're drawing as quickly as it can. So feel free to go to Quick Draw on Google and just kind of mess around with that. It's fun and interesting, but it does reaffirm our ideas of prototypes. But just kind of a more fun activity to do here. With that said, then when we talk about prototypes and concepts and we take a step back and we really think about what are the differences, right here we're conceptualizing a chair. When I say a chair, right, your best Your prototype is probably like a school chair or like a bit like an office chair, right? Maybe your kitchen table chair because you're sitting in your living room right now, whatever that might be. But can other things be chairs? Could a swing be considered a chair? Could a fence, if you're sitting on it, a box, if you're sitting on it, do they all count as chairs? And that's the question, right? That's the question we're thinking about when we're defining the difference between prototype and concept, right? Obviously, looking at this slide, these examples are more varied than one would clearly fit into your concept of a chair. So this just gets us to think bigger picture about like what are our concepts, what are our prototypes, and then by extension, what are schemas, right? So with that said, then taking a step back, reminding ourselves what a schema is, right? That's the list of characteristics that we assign to that concept, right? We looked at a schema in the context of assimilation versus accommodation, but right now here we're going to look at concept being the category, right? Fruit, right? That's our concept. Schema then would be what are the characteristics we assign to our category of fruit, right? Sweet, have a pit, have seeds, right? Those would be our schema of what makes something a fruit. And then our prototype is the best example or mental image. For me, it's an apple, right? Many of you might say apple or orange, right? I would guess most of us aren't saying like star fruit or cantaloupe, right? Those are a little bit more obscure. But again, concept, the category, fruit, schema, list of characteristics assigned to that concept, right? Have a pit, our sweet. And then prototype, our best example, our mental image of that concept, which in this case could be an apple. With that now, in that particular example of fruit, I want you to come up with your own example. And I want that example to be about police officers. So your police officer, what is the concept, schema, and prototype? Pause this real quick and just write out, what is the concept, schema, and prototype of police officer? Okay, so your concept, right, the category is, of course, police officer. Your characteristics, this is pretty interesting, and we will get into bias, both racial and gender bias, and why inherent bias exists later on in the term. But many people, when they're envisioning their prototype, right, it's often a man. Oops, there's the bell. They're generally envisioning like a man in a blue uniform with a gun and a big old hat, right? And so your schema, those list of characteristics are going to be like blue uniform, badge. Maybe a lot of people think somebody's like stout or like stocky. Generally, skin color will play a factor in that. Many people envision their prototype, right? The best example or mental image you have, a white male police officer. And so again, we're going to talk about how prototypes and what our prototypes are fit in to our inherent biases that we have later on in the term, but it is just kind of an interesting example to think about. So concept, police officer, schema, things that are attributed to that concept, right? So badge, gun, blue uniform, whatever. Prototype is what do you envision when you envision a police officer? So when prototypes fail us, right, that's when we see things like bias. When examples stretch our definitions, when the boundaries between concepts is fuzzy, when examples contradict our prototypes, right? These are examples of when these prototypes fail us. So is a stool a chair? Is this blue or green? Is a whale a mammal, right? These are all kind of things that get us to question our prototypes. And I think, again, brings us back to if something doesn't fit our preconceived prototype and what we expect, how does that help us understand where bias exists? So with that, in class, we're going to do these group kind of FRQ problem solving. So I'm just going to introduce like a few ideas here, but we'll dig more deeply into them after we do the activity in class. So there are 3 ways in which we can really solve problems, right? Problem solving refers to the thinking we do in order to answer a complex question or to figure out how to resolve an unfavorable situation. So the first is trial and error. The second is an algorithm. You have trial and error, algorithm, and heuristics. Those are going to be our 3. With that said, I'm going to just pose the example of going grocery shopping. Right now, many of you have gone grocery shopping at a grocery store that you have never been to before, and you're like, what the heck? How am I supposed to find anything? Right? With that said, the example that we're using here is we are looking for apple juice. How are you going to find the apple juice? Well, based on trial and error, you are going to wander the supermarket randomly until you find it, right? Right? Those like TikToks where people like close their eyes and they're going to have like a girls' night or whatever, and then they walk through the aisle and they like pick a random like chip and a drink and a movie. It's like that, trial and error. Algorithms create a methodological path to make sure you check every aisle. And then heuristic is check only related aisles. So looking at these and putting definitions to them, trial and error is trying various possible solutions, and if one fails, you try another. Right? An algorithm is a step-by-step strategy for solving a problem, and then a heuristic is a shortcut to saving those kind of algorithm type problems. So algorithm, no matter if you know where the apple juice is or not, and you could guess it's down the juice aisle, you would walk up and down every single aisle just to make sure you didn't miss it. Whereas a heuristic, you'd say like, oh, I know it's in the juice aisle, so I'm going to go to the juice aisle and find it there. Right? The last definition here is insight, and that's a sudden realization or a leap forward in thinking that leads to a solution. So let's see what your thinking style is. Why don't you go ahead, take a second, just pause the video and answer the following questions. Use the following key to indicate your response to each of the following statements. Place the appropriate number in the space before each statement. Okay, so to pause it and answer those questions just real quick. Okay, so now I'm going to give you, so once you've answered those questions, what you are going to do is for numbers you are going to 1, 2, 3, 4, and 5, and add you're them going to reverse together. The scores okay, and so add them together. Well, right, wait, so if you put a 5 down, count 1. If you put a 4 down, count 2. You know the drill. Once you've added those together, right, 1 through 5, once you've added those together, that's going to be your rational thinking style. If you have, right, rational thinking style. If you have a higher score, you have a greater preference towards rational processing. Things like algorithms, right? Not so much trial and error, right? You want to be spot on. Now for numbers 6 through 10, what you are going to do is just add those numbers together and don't reverse. Again, higher scores reflect greater confidence in one's feelings and immediate impressions as a basis for decisions and actions, right? So this is going to be your experiential thinking. Okay, so experiential, are you going to go based on insight? Are you going to just do trial and error, trust your gut? The apple juice is in the juice aisle, I'm just going to go and do that. Obviously, that's an easy example. But these just give you some insight into your own thinking style before we move in to those group work FRQ stations. So I'm going to have you guys do this in class, and then tomorrow we will get started on kind of the problems with problem solving. Okay, team, so today we are going to be looking at obstacles to problem solving. So yesterday in class we did those FRQ stations, we looked at problem solving, we looked at trial and error, algorithms, heuristics. You got kind of a sense of how our brains think and process and actually engage in problem solving. But oftentimes we don't always come up with the correct answer, even though we're doing what we can to problem solve to the best of our ability. So with that, we are going to look at some reasons in which our problem solving might fail. And those are going to be looking at fixation, heuristics, confirmation bias, and framing. So those are kind of the big ideas that we are going to be covering today. And the first we are going to start by
insight and what it is, right?
I referenced it just briefly yesterday, but I think now that you guys have kind of worked dig a little bit some of those FRQ practice problems, I think it's going to make a little bit more sense.
Insight and what
but
it actually
insight is essentially
like.
when we feel that
essentially
aha
what
moment.
it is.
So like when you are trying to figure out
that
which baseball player is playing which position,
when we're
and you're
working
like,
really hard,
it has to be John on third base. A problem,
like that
we're trying to
that light
figure out
bulb
which baseball player
and you're like, it has to be this
position,
oh, that's
right?
so
And all of a sudden,
obvious.
right?
That's
yeah,
the
it has to be this one.
And
When we've done psychological studies,
that's
when they've
we
attached
are
fMRIs
engaging
and
in
EEGs
insight, and
to our
oftentimes
brains,
and
based on
we're
our
asked to come up with a
psychological
word
studies
that
through fMRI and EEG.
can be a compound word with pine,
we can
crab,
see that
and
our
sauce,
frontal lobe
Give you a
lights
second to
up
think about it.
A lot more
apple,
actively
right? Pineapple,
when
crab
we
apple,
have that aha
applesauce,
moment. And that
right?
makes sense because
you hit that aha moment
decision
and you
making,
see a burst
thinking
of activity
kind of
shown in your frontal lobe. And that makes
aspect
sense,
of the
brain
frontal lobe
takes place in the frontal
where
lobe itself.
our
So
brain's
insight is really just a
thinking
burst of activity
processes
shown
are,
in
as
the
well as
frontal
its
lobe. It's that
decision
aha
making,
moment,
right?
like, oh,
because
it has to be
frontal
that.
lobe is
And
underdeveloped
we
as
all
a teenager.
experience it.
You're not all that great
at making
and
decisions. It's not totally
oftentimes,
developed, and therefore
it goes
that's why
along
the
with our
drinking
problem
age is
solving
set to 21, so we don't
And
mess
so
with the
with that,
development of that prefrontal cortex, right?
And so this all makes sense. Now let's see if we
I
can't
just want to take a quick second.
get you to experience that aha moment. Like I said in the example, right, pineapple, crab apple, applesauce, how can we make compound words out of these two sets of three words, right? So what word can we add to make compound words? I'll give you a second. Did you get it? Do you feel that aha moment? The answer is goose, goose bump, goose step, goose egg. The second one, paperback, like a paperback book, paper clip, wallpaper, right? So there's your opportunity to maybe have experienced an aha moment, but with that, an experience insight, right? With that, we're going to shift, like I said, obstacles with problem solving. So here we have a nice pick, right? We're going to look at faulty logic, right? An old cowboy walks into a bar and orders a drink. As he sits there sipping his whiskey, a young lady sits down next to him. She turns to the cowboy and asks him, "Are you a real cowboy?" He replies, "Well, I've spent my whole life on the ranch herding horses, mending fences, and branding cattle, so I guess I am." She says, "I'm a lesbian. I spent my whole day thinking about women. As soon as I get up in the morning, I think about women. When I shower or watch TV, everything seems to make me think about women." A little while later, a couple sits down next to the old cowboy and asks him, "Are you a real cowboy?" He replies, "I always thought I was, but I just found out I'm actually a lesbian." Right? Faulty logic. Obstacles to effective problem solving, right? If we aren't able to think through these problems, right? False premise. Yeah, maybe he does think about women all the time as a cowboy, but that doesn't, A plus B does not always equal C, right? And so it's important that we recognize faulty logic as a component of that. Obviously, that was a joke to give us some insight into what that actually looks like. But another example here of an obstacle to problem solving is going to be belief bias. Now, this kind of example maybe is dated last semester a little bit, but you could think about like the current election and whether or not individuals are choosing to accept results or not, or if they're saying that there has been fraud, right? Belief bias is the tendency for one's pre-existing beliefs to distort logical reasoning, sometimes by making invalid conclusions seem valid or valid conclusions seem invalid, right? It's this idea that I have this belief, and therefore no matter what you tell me or no matter what I hear, I'm going to maintain that belief, and I'm going to read news articles, and I'm going to watch news channels that reaffirm that belief, right? So this particular example, when John Bolton released his book, right, you have one side of the political persuasion saying John Bolton knows what he's doing. You have the other side of the political persuasion saying no power unchecked. Bolton blows up Trump's team foolhardily, quid pro quo defense, right? Like, depending on which political leaning you might identify with, right? You're going to read one of these articles and it's going to reaffirm your belief. That is what we're talking about when we're talking about examples of belief bias. So here's another example of belief bias. This is specifically looking at like familiarity with concepts that are being presented to us. So the top one, no Gox box when in purple socks. Jocks is a Gox wearing purple socks, therefore Jocks does not now box, right? What's a Gox? We aren't familiar with what a Gox is. The bottom one, no cars run when they're out of fuel. My car is out of fuel, therefore my car does not now run, right? The top, I'm going to mispronounce this word. I do it every time. I have to write it like in my notes so that I remember what it is. Syllogism, the like A plus B equals C, right? Doesn't make sense because we don't know what a Gox is. But the bottom one does because we understand the concepts of cars running on fuel, right? So belief bias, we are going to reaffirm certain beliefs if we understand what's being said, or we're going to discredit certain beliefs if we don't understand what's being said. Another example of belief bias is specific to content. Some A are B, some B are C, therefore some A are C, right? If we plug that in, some women are Democrats, some Democrats are men, therefore some women are men, right? That doesn't make sense. Again, this is an example of a problem with problem solving, right? When you put specific context, right, these are some nice photos, some nice Photoshop going on here. But the top syllogism makes sense. Syllogism makes sense, but it shouldn't, because certain context or contents, when placed in that syllogism, just doesn't work, right? So let's take then that idea of belief bias and transition it into an understanding so that we can differentiate between confirmation bias and belief perseverance. Confirmation bias is when you think a new law is terrible and listen to only talk shows that reinforce or confirm your belief. You think you must be right if the news says so too. What you listen to reinforces your existing belief. You looked for evidence to support your opinion and did not look at any shows or info that might disconfirm your belief. Right? This is different from belief perseverance, because belief perseverance is when you think a law is terrible, but research it and find out it is great and that your opinion is not valid, yet you hold on to your negative existing opinion and say the research must be biased, I am right. Now, this is interesting, right? Both of these are a part of belief bias, right? They're like an off branch. If you can see me, I'm like actually physically moving my arms. You have belief bias up top that branches down into confirmation bias and belief perseverance, and being able to distinguish between these two is important, right? Confirmation bias is oftentimes unintentional, right? It's this idea that we live in kind of echo chambers of our own beliefs, and we listen to the same things and they reaffirm our beliefs, and therefore we think our beliefs are right. Whereas belief perseverance is this idea that I've done research, but that research is wrong and I'm going to believe what I'm going to believe anyway. So let's talk about like fraudulent voting, right? There's been a lot of research done that says that voter fraud is not an issue that would have a direct impact on the current election outcome. And yet there are people who believe that, a lot of people who believe that there is massive voter fraud and this election was rigged and votes were stolen. And where is that information coming from? Why do people have certain beliefs? Well, some maybe only listen to certain news stations or read certain articles that tell them that that's what it is. And therefore they believe it. They hear people telling them that. They read news articles telling them that. And they're like, I must be right. Everybody else who's saying that voter fraud isn't an issue, they're wrong. Whereas belief perseverance, right, would be an example saying like, I've read all the research, I've seen all the information, I've listened to the experts, and even though they're telling me that voter fraud isn't an issue, I'm going to believe it is anyway. They're biased and they're wrong, right? So here's just a quick like cartoon to show us an example of belief or confirmation bias, right? I have a belief. Evidence you're wrong. Evidence you're right. I'm only going to listen to the evidence that says I'm right, right? And so these can be problematic, confirmation bias and belief perseverance, when we are actually trying to make our own decisions and come to conclusions about the world around us. So the question is, how do we overcome confirmation bias? And this is a test that psychologists have put into place to test people's problem-solving abilities, and it's called the confirmation bias test. In this particular example, we hypothesize that everyone who drinks alcohol at a party is at least 21 years of age. You meet 4 people of whom you know little information, limited information. The first person's holding a beer, the first person's holding a cola, the third person is 25, and the fourth person is 18. If you could find out more about just 2 of these people, which 2 would you investigate to help find out whether your hypothesis is true, right? I'll give you a second. Who would you want to ask more information about in this particular example? Quick hint, in order to test the theory, you want to find violators. You want to find violators. Who would you ask? Right, the answer is the person holding a beer and the person who is 18. Right, you want to know how old the person holding a beer is. Are they in fact older than 21? And you want to know if the person who is 18 is drinking beer or not, right? Once you figure out who those violators are, you're able to prove if your hypothesis is correct or not, right? This particular test is easy, and people generally in these types of studies do better when the test is concrete and when there's like law, like right or wrong involved. But the next slide we're going to look at is going to be a little bit more difficult. And this one says, if you are given the cards below and that have a letter on one side and the numeral on the other side, our claim is that if a card has a vowel on one side, then it has an odd number on the other side. Which 2 cards would you turn over to find if the claim is true? Pause it and think about it. So this one's harder, right? And that's because it's not like a real life situation. There aren't like moral right and wrong legal code issues involved. But basically going through these different cards, right? If you flip over A, you could confirm or disprove the claim, because if you flip over A and you see that it either has a odd number or an even number on it, you're going to know it's either true or not true, right? If you flip over D, you're not going to learn anything, because there's no claim about cards with consonants on one side. We know nothing. We don't really care about what the consonants have. Flipping over the 6 is going to be crucial, right? Again, we want to find violators. So if the 6 were to have an odd number on, or a vowel on the back, right? A 6 being an even number, if it had a vowel on the back, we know that this claim is untrue, right? And then the 7 gives us a chance to confirm, but it doesn't give us a chance to disprove. So in this particular situation, you'd want to flip over the A and the 6. Did you get it right? The A and the 6. Again, we want to find violators. We want to disprove it in order to confirm whether our claim is accurate or not. And again, this is that confirmation bias test that helps us overcome confirmation bias within research studies. Right, and good science is not about challenging our theories, challenging our theories to see if they hold up. To do this, we need to find cases of confirming evidence. Kids, to explain that further, particular, right, the ultimate test of our mastery of confirmation bias in psychology might be our ability to avoid that confirmation bias in research. This is a particular example. If we believe that overeating candy is the main cause of ADHD symptoms, what types of people do we need to look for to really test out our theory, right? We're going to need to find kids who eat a lot of sugar, kids who don't eat sugar, kids who have ADHD, and kids who do not have ADHD, right? To do this, right, and in order to engage in the confirmation bias test, we need to find cases of kids who do not eat candy. And if any of them also have ADHD, that would be how we disprove our hypothesis. So you're seeing how this confirmation bias test fits into, like, think back to Unit 1 of regular psych and our testing strategies. it's important to recognize that we don't just want to say like, oh yeah, when kids eat a lot of sugar, they have ADHD symptoms. Like, we have to figure out a way, how can we disprove that and potentially overcome the confirmation bias that inherently exists in all of us. So with that, then we're going to shift and look at other problem-solving habits, one being mental set and one being fixation. The way we overcome these is through intuition, which you'll see on the next slide. Mental set is the tendency to approach problems using a mindset that has previously worked before, right? So we go into a problem-solving activity with kind of experiences that have worked for us in the past, right? Fixation is the tendency to get stuck in one way of thinking, an inability to see a problem from a new perspective. So how do we overcome this, right? Like I said, through intuition. We're going to do a couple of examples here of mental sets and fixation. The first one, how are you going to arrange 6 matches to form 4 equilateral triangles? What's going on if people struggle on this? What assumptions might be fixed in your mind, right? I'll give you a second to try and think about how are you going to organize these matches. Feel free to pause it if you're like, I'm going to figure this out, but I'm going to give you the answer here, so no spoilers. Ready? Right? Our mental set, perhaps from our past experience with matchsticks, assumes that we are arranging them in 2 dimensions, right? How many of you were trying to make like a little house shape out of, here, I'll show you what I was, when I tried to figure out how to do this, I was going like 1, 2, like trying to do something like this, and I couldn't figure out how to do it. But that's because my mental set is telling me like I have to arrange them flat. This type of fixation has been called functional fixedness. Okay? Functional fixedness is the assumption which makes this problem difficult, is that problem must be solved in 2 dimensions, right? Functional fixedness is a specific type of mental set that involves only being able to see solutions that involve using objects in their normal or expected manner. Okay, so this is this idea of functional fixedness. Okay, specific type of mental set that involves only being able to see solutions that involve using objects in their normal manner. We're actually going to watch a video to kind of combat functional fixedness, but let's do a couple more examples here first. Okay, your next task, use 4 straight lines to connect the 9 dots. Okay, again, I'm going to let you guys work through this on your own. Again, if you're somebody who's like, I'm going to figure this out, feel free to pause the video and work through it longer, but I am going to give you the answer here. 4 straight lines to connect the 9 dots. I'm going to give it 3, 2, 1. Solving this requires escaping fixation by thinking outside the box. Literally thinking outside the box. Right? How many of you were trying to be like 1, 2, 3, right? Like trying to keep everything within those examples, right? This is an example of fixedness because we can't think outside the box. Another example here. Can you use only 3 straight lines to connect these 9 dots? Right? You've been primed. This one is probably going to be a little bit easier for you to figure out. Right? You're like, oh, I don't have to stay within the lines. Let's try this. I'm going to get through 3. Now, again, this is tricky because we're not directly going through them. Right? We're just going through part of them. We're not going straight through the middle. Well, that was a terrible line, Miss Ellis. Right? We're not going straight through the middle. But that's another kind of fixedness example of us trying to kind of come over that, what it means to connect the 9 dots, right? Air quotations, connect the 9 dots. Right, now let's shift and look at mental set. So those were examples of fixedness, right? We're going into it with this idea of we have to work in 2 dimensions or you have to keep everything within the lines. Here's a mental set. Okay, what are the next 2 blanks within these sequences? Again, I'll give you some time, but pause it if you really want to think about it harder. Okay, I'm going to give you the answers here. So if you want to keep working, pause it. The first one are numbers, 1, 2, 3, 4, 5, 6, 7. The second one is months, January, February, March, April, May, June, July. The third one are alternating alphabet, right, backwards and forwards. And then the last one is actually the question at the top of the page. What is the next in these sequences, right? And so this mental set is something that we looked at yesterday with those FRQs when you were working through kind of those math problems, and it was asking you how to like add up water jugs or whatever the question was, right? And they were all the same except for the last one. And it was tricky, but that's your mental set, your brain setting up like this has worked for me in the past, so I'm going to continue to try and use that same method to find the answer. So like I said, we are going to watch a video example of overcoming functional fixedness. Again, just being specific, functional fixedness is this idea that we are stuck using certain tools in the manner with which they're supposed to be used, right? That example, matchsticks flat on the table as opposed to in a three-dimensional pyramid. But here's going to be another example of that. So there was an example of functional fixedness, right, with those giant paper clips and how we can think outside the box and overcome functional fixedness to use paper clips in ways that they weren't necessarily like made for, functioned for, right? And so with that, we are going to shift our attention now here to the different types of heuristics that exist that lead to problems and problem solving and our ability to like understand what's going on in the world around us. And so the first one is going to be availability heuristics. We're also going to look at representative, anchoring, and gambler's fallacy as they kind of pertain to our understanding of misperceived understandings. So what we're going to do now is another little experiment. This one's full of experiments, and actually this is one of my favorite lectures to give when we're in class, but here we are. So what I want you to do is I want you to silently read each of the following words as they're presented in this video, okay? I just want you to silently read them as I worked through them, okay? Okay, so were there more male or female names presented in the previous slide? There were 14 male and 10 female names actually listed in these slides. And it's interesting, right? Like you can tell all of the male names are non-famous people and all of the female names are famous people. And that leads us into our understanding of availability heuristics. So availability heuristics are problem-solving shortcuts for judging likelihood of an event to happen in terms of how readily it comes to mind. This is often based on vivid personal experience or media exposure and can result in either correct or incorrect analysis of the situation. So in this particular example, right, how readily it comes to mind? Well, the names that probably popped into your head after reading through all of those names were probably people like Taylor Swift, Beyonce, Hillary Clinton, right? Like names that you know. It probably wasn't going to be the John Tabors and the Jason Dorseys that you've never met before. And so availability heuristic, you're more likely to pull those female names and therefore think there were more female names than male names in that list. Another really good example of this is like plane crashes or shark attacks, right? They're more often portrayed in the news when like a plane crashes or when there is a shark attack. But we're not hearing about the millions and millions of people who fly every day or swim in oceans every day that aren't getting eaten or dying in plane crashes. But because the vivid personal experience or media exposure of those plane crashes and shark attacks are so prevalent, we are still afraid to fly in planes. We are still afraid to swim in oceans, even though the likelihood of one of those events happening is severely minimal. One more example here is the idea that many assume that judicial trials are common and plea bargains are rare, right? My husband and I are currently watching the TV show Suits. I don't know if you've watched it before, but it's about like lawyers in New York and they're like whatever, big shots. But we so often see in like TV and news media when like things are really bad, when there's like a murder or some sort of like extreme case, right, that goes to trial, we have this perception that most court cases go to trial when in reality, that's very uncommon, right? News reports of trials tend to be more sensational than reports of plea bargains, which cause us to expect them to happen more often and have them pop into our minds first, right? The reverse is actually true here. It's far more common for court cases or court hearings to end in plea bargains than it is for them to end in trial, right? And that's, again, just another example of an availability heuristic. What comes to mind when we think about court cases is being in court, right? And therefore, we make certain assumptions that are not grounded in actual fact, just based on this idea that that's what we perceive more of. Okay, I have definitions of these on a future slide, so don't freak out too bad that for availability and representative heuristics we don't have definitions, but I am just going to talk through some examples of representative heuristics. This example actually goes through. Feel free to scan it on your phone. You might need to scan it on your iPad. I'm not positive because you need Flash Player to work through it, but it essentially tells you there's 20 people that live in a town, 10 are professors, 10 are truck drivers, and then they give you a description of 20 people, and you have to decide if they are a truck driver or a professor based on that description, right? And you can imagine, right, they'll give a description. This 6'2" man is wearing a flannel and a baseball cap, right? You're going to probably say he's probably a truck driver, right? This person is wearing a tweed jacket, carrying a briefcase, and wearing spectacles. You're going to say, like, he's probably a professor, right? And it just plays on that idea. Representative heuristics is this idea that we have prototypes in our brain. And those prototypes, right, our most common idea or best example of a professor or a truck driver comes to mind, and we make certain assumptions based on those prototypes. And that's what we're talking about when we're talking about a representative heuristic. So I'm making a shortcut, right, making an assumption, a heuristic, a shortcut, an assumption based on my prototypes. The last type of heuristic that we're going to look at is anchoring heuristic. So if I were to ask you, how long is the Mississippi River? And I were to, in class, what I would do, sorry, I'm like apparently distracted. I'm literally just talking at an iPad screen. So I don't know what distracted me. Regardless, I would actually send half of the people in the hall and half of the people would stay in the classroom. And I would ask the first half of the class, and I would say, hey, is the Mississippi River longer or shorter than 500 miles? How many miles long do you think it is? why don't you guys go ahead and take a second? Do you think that the Mississippi River is longer or shorter than 500 miles? And how long do you think it is? Okay, once you've made your guess, obviously the second half would come in and I'd say like, is the Mississippi River longer or shorter than 5,000 miles? How many miles long do you think it is, right? The first group I asked, was it longer or shorter than 500? The second group I asked, is it longer or shorter than 5,000? And you would be able to tell, we graph the total guesses within the class, and those who were primed, right, or were anchored in 500 miles would guess that the Mississippi River was a lot shorter than those who were anchored in this idea of 5,000 miles. So essentially, anchoring heuristics is when we are primed to give an assumption based on some like already given piece of information. So here we go, real quick, those definitions. I know I already talked about the examples here, but feel free if you want to write these down or like just take a screenshot and copy them into your notes. Availability heuristic, just as an overview, right? We use these when we estimate the likelihood of an event based on how much it stands out in our mind or how much it's available as mental reference. That's why people think they win or they're going to win at the casino, because you only hear when like all the like loud noises and buzzing and flashing lights when somebody wins, right? You don't hear every time somebody loses. So you think that winning at a casino is far more common than it actually is, right? Because that's what we have as an available mental reference. A representative heuristic is when we use these to categorize a situation based on a pattern of previous experiences or beliefs about that scenario, right? Again, that prototype, we're coming in with certain biases, with certain expectations about like who is who and what is what, right? That's why another example of this, like identity fraud, like elderly people will let people or like somebody wearing a suit into their home a lot more often than they would let somebody who's just in like street clothes, because they have an expectation if you're in a suit, you're a professional and you're not here to harm me, whereas we know that's not necessarily the case. A lot of fraud goes on that way. And then the last one here is anchoring heuristic, and this is that we accept and rely on the first piece of information provided before making a decision. That first piece of information is the anchor and sets the tone for everything that follows, right? Mississippi River. If I asked if it was longer or shorter than 500 versus 5,000 miles, that changes where you think your starting place is, right? So those are just your definitions. You will need to be able to differentiate between availability, representative, and anchoring heuristics. So just kind of keep that in mind as we add this idea of gambler's fallacy to the mix. So gambler's fallacy occurs when an individual believes that a certain random event is more or less likely given a previous event or a series of events. Right? This line of thinking is incorrect since past events do not change the probability that certain events will occur in the future. A really good example of this is when you're flipping a coin. If you flip a coin 10 times and get heads all 10 times, people believe that that next flip, it has to land on tails, right? Like it just has to. You can't get heads 11 times in a row, right? But really, the probability of flipping heads or tails doesn't change. It's always been 50%, right? From one flip to the next, you're no more or less likely to get an outcome based on the previous outcome. Another really good example is my favorite football team, the Minnesota Vikings. They never ever win, right? But they're always in it, and they always get my hopes up, right? And so every year I'm like, this has to be their year. They should have won it last year, so they're probably, there's no way they don't get to the Super Bowl this year, right? Any sports team, right, that has contended for a national championship every year, you always and they always lose in the final round, right? This year is going to be their year, and I feel that all the time with the Minnesota Vikings, and they break my heart. I'm actually wearing a Vikings shirt today. It's game day, baby. But yeah, so these are examples of gambler's fallacy. And so that kind of ties up our bow on heuristics as we move into talking about framing and intuition. Those are kind of our last two ideas. And then you have a formative to take to then differentiate between the different types of heuristics. So kind of keep that in mind as you move ahead. Like I said, framing, and intuition are our last two ideas. Framing is the principle that our choices are influenced by the way they are framed through different wordings, settings, and situations. Advertisements, commercials, magazine ads, like they use this all the time, right? If you look at this particular example, right, you have frozen yogurt is 80% fat-free versus 20% fat. People are far more likely to buy the 80% fat-free because people are health conscious and they want to lose weight or whatever, and so they buy the 80% fat-free sounds better for you than 20% fat, even though it's the exact same amount of fat, right? That's their framing effect. Another example here, when we're talking about why, you guys have all seen those, like, in the arms of the angel, fly away from here, like the Sarah Evans and like the sad dogs at the pound, and like why you need to donate to save these puppies and they're so sad and all you want to do is help them. Well, that message is being framed, right? If you donate, right, you could frame it positively, right? If you donate money, this cute bunny will live happily ever after, right? Think about the puppies in the Sarah Evans or Laughlin commercial, right? Or you can put a negative frame on it. If you don't donate money, this cute bunny will die, right? And generally speaking, those Sarah McLaughlin, right? I think it's her, not Sarah Evans. Sarah Evans was like, she put her suds in the bucket and her clothes hanging out on the line. Yeah, that's not her. It's Sarah McLaughlin. I digress. With that, they're generally a negative frame because they're like, if you don't donate now, these puppies are going to be euthanized. They're going to be sent back to like terrible homes. And so people feel incentivized to then donate more often than if you were like, donate and this puppy will be happy, right? So framing effect is really important as we're trying to understand the world around us. How are we being framed to understand the world around us? And then the last point here is intuition. And it really is just that, right? It's intuition. It's our gut feeling, right? In complex situations, it helps to use careful reasoning to avoid mistakes made by intuitive judgment, right? Research supports that sometimes we need to let our unconscious mind go, right? To just kind of, sometimes this is essentially what this is saying. Wow, this is tough for me to say apparently, is that like a lot of times we overthink things and we think things are far more logical than they are, but sometimes we do really just need to go with our gut. Incubation specifically is the power of taking a break from careful thinking, even to just sleep on it. And oftentimes this leads to leaps in cognition, right? If we're trying so hard, I feel like, I don't know, like my husband works at Medtronic and he is currently working on like a product launch for the pelvic health unit within Medtronic. And there are certain problems with like giving people access to Zoom on their like Medtronic issued phones. And so maybe it would be really good for him, instead of just trying to work on it all day and touch base with all these different people, to just take a step back, take a break, let his brain kind of process everything and then come back to it later. And oftentimes people see after this incubation time that they are a lot more productive, right? Times that in using your intuition is effective is when it is a product of expertise built up from trial and error. This hones one's judgment to be the point of being more accurate than logical analysis, right? There are people, and they talk about this in the textbook. If you're not reading the textbook, that's totally fine. But an example of this is like there's people who literally like chicks, baby chickens, like little chicks get like sent down a convention, or what is the belt? Like a conveyor belt, and they like look at tens of thousands of chicks a day, and there's really no way I couldn't tell the difference between a female and a male chick, but these people can like look at them real quick and toss one over, and like literally they kind of toss them because their bodies are just basically cartilage at this point, into the female pile and some into the male pile, and they can just look, and based on intuition they can do it just because they've been doing it so often. Based on that trial and error, they can use their intuition to tell the difference between male and female. Another example, speed chess, quarterbacks making decisions, right? Any sports player really making a decision, a lot of times you don't have time, you don't have the opportunity to like think it through. You just have to go based on that intuition. And oftentimes this is one way to kind of engage in problem solving and that we don't really think about. It has problems in and of itself because if you're not using logic, right, there are always opportunities for error. But there are instances in which intuition can be a better method for problem solving than things like heuristics or algorithms or trial and error, whatever it might be. So with that, I'm going to transition. You guys have a formative to complete. The heuristics and algorithm formative. It is on Canvas, so take access or take an opportunity to complete that to make sure you're feeling comfortable looking at the differences between those problem solving methods as well as the differences between the different types of heuristics, okay? Awesome, nice work team. First lecture in the books. Check it off. Whoop whoop.